What if reality wasn't real? What if the solid world you see is really waves, probabilities, and ghosts of possibilities? This is the paradox and the power of quantum mechanics in 25 facts. Cracking reality. Quantum mechanics is the science of the very small, atoms, electrons, and particles smaller than light itself. Unlike classical physics, which is predictable, quantum physics runs on probabilities. Nothing is certain until it happens. In 1900, Max Planck suggested energy comes in tiny packets or quanta, not in smooth waves. It was the birth of a revolution. Einstein expanded this idea in 1905, explaining light itself is made of particles called photons, launching the quantum age. Today, quantum mechanics is the foundation of modern technology. Lasers, semiconductors, computers, even your smartphone screen. Quantum mechanics isn't just theory, it's everywhere, shaping reality itself. Stranger than fiction. Electrons don't orbit atoms like planets. They exist in clouds of probability, blurry, ghost-like positions until observed. The famous double-slit experiment shows particles act like both waves and particles until you watch them. Observation changes reality. Werner Heisenberg's uncertainty principle says you can't know both a particle's position and speed with perfect accuracy. Nature hides its secrets. Particles can exist in multiple states at once. This is called superposition. Schrödinger's cat, dead and alive in a box, is the strangest metaphor of all. Until you look, reality is undecided. Quantum mechanics isn't just weird, it breaks our very definition of real. But what if particles aren't just uncertain? What if they're connected across space and time? Entanglement and beyond. Quantum entanglement links particles so completely that a change in one instantly affects the other, even across galaxies. Einstein mocked this as spooky action at a distance. Today, experiments prove it's real. Entanglement is the basis of quantum teleportation, already achieved in labs moving information instantly between photons. China launched a satellite in 2016 that demonstrated quantum entanglement across 1,200 kilometers. Some researchers suggest entanglement could one day build a quantum internet, faster, unhackable, and universe-spanning. Entanglement shatters the limits of space. It suggests reality is more connected than we ever imagined. Powering the impossible. Quantum mechanics powers transistors, the tiny switches inside every computer chip. Without them, no digital age. Lasers used in medicine, communication, and entertainment are purely quantum inventions. Quantum mechanics explains why the sun shines. Nuclear fusion in stars depends on quantum tunneling, where particles slip through barriers. Quantum tunneling also drives technology like flash memory in your phone. Now scientists are building quantum computers, machines that use superposition and entanglement to solve problems classical computers never could. Quantum mechanics isn't just theory, it's the backbone of our future. The great unknown. Quantum physics and Einstein's relativity are both true, but they don't agree. A full theory of everything is still missing. Some interpretations suggest infinite parallel universes, where every quantum choice creates a new reality. Others argue quantum mechanics only makes sense if consciousness itself plays a role. Are we shaping reality by looking at it? Physicists are testing quantum mechanics at larger and larger scales, trying to see if the weirdness extends beyond particles. In the end, quantum mechanics may not just describe the universe, it may describe why the universe exists at all. Quantum mechanics is not just science, it's the edge of reality itself. Here's the twist. Every time you open your phone, use GPS, or turn on a light, You're wielding the rules of quantum mechanics. The very science that defies logic is the science keeping our world alive. The quantum world is strange, unpredictable, and maybe even infinite. But it's also proof that the universe is more mysterious than we can ever imagine. Love science, mysteries, and the future of physics? Don't forget to like, subscribe, and share as we learn more together.